Hello, my name is Harry Lythall and I am SM0 VPO Swedish amateur radio station. Of course I'm British. My previous call sign was G4VVJ in England. But when working in Saudi Arabia, I met a beautiful Swedish girl and we got married, moved to Sweden, and now we are living happily ever after. Okay. I've got my own home pages at www.sm0vpo, and there you'll find a few hundred projects that I've built. Please surf in and have a look at the projects. They're all totally free, including printed circuit board patterns, software, whatever. I also have my own forum, so that if you've got any questions about this video or any of the projects on my home page, please, you're welcome to log in, post questions. What I'm going to talk to you about now is the Grid-Dip Oscillator. Okay, now Grid-Dip Oscillator is really old technology, but then again I'm 66 years old now, so I'm also old. It was developed around about 1930, 1940, but modern GDOs, they use a field effect transistor, the FET, so they just call them a dip oscillator. But I'll stick to GDO if you don't mind. The GDO is perhaps the most underestimated piece of test equipment in the radio amateur's workshop. Now, you can use it for all manner of functions. For example, you can use it to simply measure the frequency of an external tuned circuit. If you tune the GDO through the frequency bands, then when it is resonating, when it is at the same frequency as an external tuned circuit, you get a dip in the current drawn by the oscillator. So you can read on the scale what the tuned circuit frequency is. So when you're winding your own coils and capacitors, it makes it very, very easy to hit the right frequency. Okay, take this a stage further. If you, let's say, you're building a receiver or a transmitter, okay, with a transmitter, let's say an old-fashioned transmitter for VHF FM, you've got a crystal oscillator, multiply stages, and a power amplifier stage at the end. Okay? If you tune a stage and hit the wrong harmonic, then the next stage won't have the right frequency and you waste time fault finding. With the GDO you can eliminate that. You just closely couple the coil on the GDO to the tuned circuit and adjust it for the resonance. Then you set the next frequency on the next stage and adjust the next stage for the correct frequency. And in this way you can actually tune a transmitter and before you even apply power to it, so that when you do apply power you've already got a signal. All you have to do is to fine tune the multipliers and tune the output stage. You're working on a receiver. The GDO is an excellent little quick and dirty signal source. Does the receiver work? Whip it through the band, smash in, and therefore you can just check that the receiver's working. Okay, let's say you're building an antenna. Okay, I can climb up a tree to tune my HF amateur radio antennas. I've got a 40-meter antenna at home in Spain, and that 40-meter long antenna works on the 3.5 megahertz band. So I climb up the mast, I loosely couple my Grid-Dip oscillator to a short circuit on the feed loop, and then when I whip through the band I see exactly what frequency the antenna is resonant at, and then I can clip the ends of the antenna to get exactly the frequency, and so I can transmit into it without any antenna tuning unit or ATU. This is great, this is. For VHF, if you're building, let's say, a Yagi antenna, you can do exactly the same thing. Short circuit the antenna feed point with a little loop, couple in the GDO and check the resonance of the antenna. Prune the lengths of the elements to get you the correct frequency. But you need to feed a VHF antenna. It's a balanced antenna and your cable, coaxial cable, is unbalanced, and so the balance can be a half wavelength of cable. Okay? Now half wavelength multiplied by the velocity factor of the cable, because radio energy travels slower in cable than it does in the air, about 2/3 of the speed. So what you can do is set the frequency you want, have a quick tune roundabout, see that your half wavelength coaxial cable, shorted at both ends, resonates at the correct frequency. If it's too low a frequency, you can clip a bit off the end until it resonates at the correct frequency. God, it's simple, isn't it? And also, it generates a signal. I've also put modulation on mine so that I can switch it on and have a microphone or a 1 kHz test tone. Alright, take the scenario. You've got a guy on the beach, 10 metres away from you, with his raster blaster, dunker, 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 dunker. Oh, I hate those. I want to lie on the beach and have some peace and quiet, no problem at all. Pull out the GDO, put on the VHF coil, and sweep through the band, switch on the modulation. There it is. You hear it. Goodbye FM radio. Okay, I'm a bit mean. I do have a mean streak. If you want to be really mean, you can have a bit of a play. Marlies, my wife, she says that men never grow up. They'll always remain children. So if you have your GDO tuned to 8.2 megahertz and put the GDO in your top pocket, do not go out of a supermarket that's got these electronic goods theft detectors. It will set off the alarms. Okay, stand beside the sensor, and when somebody else goes out, you just sweep through the band and the alarm will go off. Bells, whistles, klaxons, and the security will go run after them. Then when the next one goes out, you sweep through the... Sorry. I'm only kidding about that. But there are lots of other uses. I mean, I plugged a microphone into mine. I've got an external modulation input, so I can use it as an FM wireless microphone. I've even got the 222 stereo encoder on my home pages, and I plug that into it, and hey presto, you've got a stereo FM local radio for within like 5 or 10 meters of the thing. There's lots of things you can do with it. Now, the way that the circuit works is an ordinary little Hartley oscillator, and the external coils, there's not one, but I've got a variety. I've got 6 coils to cover 1 megahertz through to 180 megahertz. You select the coil that you want, and the oscillator itself is used as one resistor in a 4 resistor Wheatstone's bridge, and the balancing point between them connected to the meter is you can use the potentiometer to balance it out so that you get 0 volts. And that way you can use a very sensitive meter, and when you get an external tuned circuit, you can have it very, very loosely coupled, and you see a fantastic dip. So the Grid-Dip Oscillator can be used to measure lengths of cables, trim antennas, trim balance or tuned balance. It can be used for a few ulterior purposes, but you can do almost anything with a GDO. It's a fantastic piece of equipment. The cost to build is around about $10 American. My first one was built about, 37 years ago now. Oh. And I use that one when I'm presenting courses to teach radio frequency techniques to people. And so I use this to actually talk about wavelength, and I check the dip of a long piece of wire. Unfortunately, my old meter is a bit old in the tooth, although so am I. It's a bit old in the dial that I created on it was written with pencil and biro. And after about 10 years it started to look a bit scruffy. But now, today, after 37 years, it looks very, well, it's almost unreadable. So I use a frequency counter beside it just to check the frequency. But the new GDO2, I've got a complete plastic dial that covers the whole of the scale. The scale itself is the same size as the meter. I've got a jumbo meter in there, and it looks a lot more technical, posh and professional when I'm demonstrating to people. So I hope that you have fun with the Grid-Dip Oscillator and have a bit of a look at some of the uses of it. Look at the uses of the GDO1, and I'm sure that you're going to learn an awful lot. It's a beautiful piece of equipment, very, very underrated. Have fun with it, and you be careful with those ethics. Goodbye.